Good morning, everyone. Today we're going to start our discussion on regression diagnostics. Now we learned that when we construct a model where we would want to explain a variable of interest using other predictors or other variables, we make use of what we call the regression model using OLS, ordinary least squares. Okay, there are other methods like, for example, the maximum likelihood estimation (MLE). Okay, but that's for another topic. But one of the let's say one of the most popular and one of the most common way to model your data is ordinary least squares, and it has its many benefits or advantages. However, there are certain assumptions that come with it. And we discussed some of these assumptions before, but we're now going to look at them in greater detail. So let's go back to the data that we're using. Okay. Okay, do I have the data? So make sure that you upload first the data. Okay, wait. Just copy the code so that I don't have to write. Okay. All right. So please load the data if you don't have it yet. Okay, since I'm using the project that we created, this will work because I will not need to identify the file name. Okay, so make sure that the file that you, I forgot to tell you about this, make sure, as always, class, when you load the file, make sure you're loading it in the project that we created so that it will be easy for us to open the data, open the file. So let's load, if you haven't loaded the data, okay, I have already loaded it, but let me erase everything here. Okay, erase everything here also, so that we start from scratch. Okay, so let me load the data first. Okay, so the data is now loaded, it's ready here. Then, if you recall, summary, let's just include summary already. Okay, and let's no, summary, and then let's create a model. Let's call it FIT1. Okay, FIT1 alt minus is we're using LM. We're regressing hourly wage on education, and then tenure, and then gender, and then civil status. This was what turned out in our stepwise regression backward, right? These are the 4 significant variables using the P method: education, tenure, gender, civil status, and then we identified the data to be equal to wage. All right, and then we print it already. Summary, FIT1. Okay, am I okay? 1, 2, 1. Okay, so by way of review, okay, this is our model. Education, tenure, gender, civil status. So just a quick review about this. It means that this 0.53 approximately, the coefficient for education means that for every 1 unit change, 1 year increase in education, there's a corresponding $0.53 increase in hourly wage ceteris paribus. Same thing with tenure. For a 1 year increase in tenure, there's a corresponding $0.154 increase in hourly wage ceteris paribus. And then the 1.7 here indicates that on the average, male counterparts receive $1.71 more then their male employees receive $1.71 more than their female counterparts, ceteris paribus, and also single respondents, single employees receive around $0.69 less than their married counterparts, ceteris paribus. Okay, and these are all significant predictors based on their p-values. Okay, you're also given here the standard errors. Okay, and then the overall goodness of fit test, where we're testing all the parameters. Beta 1 is equal to beta 2 is equal to beta 3 is equal to beta 4 is equal to 0. And our conclusion is that we reject that null hypothesis. And there's strong statistical reason to believe that at least one of these parameters, either education, B1, B2, B3, B4, is significant. Okay, and then we looked at the degrees of freedom. For degree of freedom 1 here referred to your number of predictors, and degree of freedom 2 refers to n minus k minus 1, where n is the number of observations, which is 526, minus 4 minus 1. 1 accounts for the intercept that need to be estimated also. So there's a degree of freedom lost there. The adjusted R-squared is 36%, which means that 36% of the variation of your dependent variable hourly wage can be described by our model, which includes education, tenure, male, and single. All right, let me pause for a while. I went through that very quickly because we already discussed that. Any questions about that, class? Could you kindly please chat and tell me if that so far is clear with everyone? I hope that's clear with everyone, please. Okay, good, thank you. How about the others, please? Requesting your feedback if that part of the discussion is clear to you. So if I, for example, if I give you a regression output, you'll be easily able to describe or define that. All right. Now I gave you here a summary report of the regression model. In your quiz, you will have to do this. So here I'm assuming that we already did diagnostics. That is already the final model. So take a look at this summary model. Okay, so this is what you usually, how you usually state it using APA format. Okay, so take a look at this. We fitted a linear model estimated using OLS to predict hourly wage with education, tenure, gender, and civil status. Where the formula is hourly wage regressed on education plus tenure plus gender plus civil status. The model explains a statistically significant and substantial proportion of variance. R-squared is 0.37. You notice 2 decimal places lang, no? With F statistic, degree of freedom 1, 4, degree of freedom 2, F21, 521, is equal to 74.95. Where did we get this, class? We got this here, ba? Ito, 74.95, right? And then p-value is 0.001. Okay? Adjusted R-squared is equal to 0.36. The model's intercept corresponding to education is equal to 0, tenure is equal to 0, gender is equal to female, civil status is equal to married. Okay, I hope this is clear, class. I hope this is clear to you. Is at negative 2.16. So where did we get that negative 2.16? Okay, it's here. It's the intercept. Okay, so this, as you recall, the intercept is the value of your hourly wage, the average value of our hourly wage when all your predictors are equal to 0. Education is 0, tenure is 0. The gender male is equal to 0 means that this is gender. If it's 0 means it's the reference, it's the benchmark, which is female. And also civil status. When civil status is 0, it means it refers to the married respondent. Okay, that's why it's stating here. Okay, civil status is married, gender is equal to female, and the intercept is negative 2.16, and then have here the confidence interval, negative 3.43, negative 0.9. So you can see here that for the confidence interval, it will not include 0. Okay, if this was negative and this was positive, then there's a possibility that the intercept is equal to 0. Okay, but for this one, we're 95% confident that the real value of your intercept lies between negative 3.43 and negative 0.9, and it will not include 0. T value is 521, is equal to negative 3.37, and P is less than 0.001. Okay? All right, any questions about that? Where did we get the confidence interval, class? Where did we get the confidence interval? Anyone? What did you learn in your prior econometric or statistics subject? Okay, well, in the interest of time, you can actually compute for that. How do we compute for the confidence interval? Well, the formula is whatever your beta is, beta sub I, okay? Now let me just write it here. So to compute for the confidence interval, this is just, well, I hope this is just a review of your stat. It's equal to beta sub I, okay, plus, since it's an interval, so it's either plus or minus, okay, your T stat times your let me start with the standard error times your T stat. Okay, so that's just the formula to compute for the confidence interval. So let's see for intercept. Let's copy this. Control C, Control V. Okay, so let's first take a look at the plus. So negative 2.16 plus your standard error, multiplied that by your T value. Okay, and then this will give us negative 4.3. Wait, tama ba? Negative 3.43. Bakit? Negative, am I correct? Standard error times 3.36. 2.6 times plus 2 plus minus. Yeah, I think that should be correct. No? Kaso bakit iba? 2.16. So that's your 2.16, that's correct? Plus your standard error times your T value.
Sir,
Yes?
hindi po ata dapat yung T value. Dapat po yung times critical value po.
Ay, oo nga pala. Sorry. Yeah. I'm sorry. Yeah, that's correct. Thank you. Sino yun?
Evan, sir.
Evan. Oh, Evan is correct. No, it's not the T value. It's the T critical. So we will have to compute for the T critical at 95% interest. No, 95% confidence level or alpha of significance level of 95%. But we will not go there anymore. Yeah, Evan is correct. Sorry. Medyo nalito ako dito. That's correct. We should be multiplying it by the T critical. Pero pwede natin ma-solve yung kay R, no? Pero ganito na lang muna, no? Pwede namang confidence interval. There's a function called confidence interval. And then we get the confidence interval, okay, for our model FIT1. Okay. And then here we have, ito na, no? We already have the confidence interval for all the parameters. So it's negative 3.4 and negative 0.9 for the intercept, etc. And if you notice that our confidence interval do not touch, okay, or do not include zeros in the interval. Okay, so since they do not include zeros in their intervals, though, so in this case, we reject the null hypothesis for our individual tests that these parameters are equal to 0. So for example, for education, the null hypothesis here is that beta 1 is equal to 0. Okay, and since 0 is not included in this confidence interval, so there's the probability for the parameter, the coefficient of education is equal to 0, is the probability that it will be equal to 0 is practically 0, or it's less than 5%. Okay, it's less than 5%. So we reject that null hypothesis. Okay, thank you, Evan, for that. Yeah, Evan is correct. We're not going to multiply it by negative 3.66, but rather for the critical value, T critical of 9%. Okay, but I won't go there anymore. Okay, although madaling-madali lang kay Aryan, na-compute natin T critical for a level of significance of 5%. But we just want to see where this was obtained. Itong ano na to, itong 95% confidence interval between negative 3.43 and negative 0.9. Okay, so you can do that. You can get that using the confidence interval function. This one. Sana. This one, class. Confidence interval of our model fit. All right. Any questions, class? Okay, paki-chat naman please kung so far naintindihan yung yung portion ng report na yan. Hello, class? Kindly chat please if for this portion, class, naintindihan yung yung report na to. So this is standard. You don't have to invent how you're going to write using APA format your regression result. Diba? At least pinakita ko, I already showed you yung dekahon na approach. You just have to follow this. You just have to of course, change the variables and then the values. Okay, good. And then you have now the individual test. The effect of EDUC is statistically significant and positive. Okay, where did you get the positive? Because the coefficient is positive, the 0.53. And notice that dito sa mga reports, class, 2 decimal places lang. You don't have to be very accurate at 4 decimal places, 5 decimal places. 2 decimal places is sufficient. Beta is equal to 0.53. Again, 95% confidence interval. Saan din ang galing yan? Dito. Okay, dito. But then I said, class, you can compute for this. Madali lang to. 0.44 and 0.62. Okay? And then, you're given also the standard beta, the 95% confidence interval. Okay. Standard beta. Okay, where can we get the standard beta, class? For education. Is it generated here in the results? Okay, wala siya, no? Hindi pinapakita dito yung yung standard beta. Okay? How do you generate that? So I will leave that to you, class, to find out. Binigay ko na sa inyo yung yung value. Yan. Andito na yung value. Okay, so that's actually very easy to generate, no? But I will leave you at least with some responsibility to look for that. Okay, and then to take note, class, that the standard beta will always be between the confidence interval. Ganun din naman tong beta na to. Okay? So the unstandardized beta, 0.53. Okay? Of course, class yung standardized beta is when we replace the education with the standardized values, which means that you transform the value. You have the value education, and then you subtract the mean of education and then divide it by the standard deviation. That's how you standardize your value. And that's very easy, class. I-research nyo, class, kung paano, how are we going to use R to regress your hourly wage using standardized values. That's very easy. Okay, so ganun din tong si gender, class. Statistically significant and positive. Okay, given din yung mga values niya, and then also civil status. Okay. And to, class, yung sinabi ko kanina, standardized parameters were obtained by fitting the model on a standardized version of the dataset. Okay, and then yung 95% yan gumagamit ng t-distribution and walled, kasi maraming klaseng t-distribution. So for regression, it's normally a walled t-distribution. Okay, all right. So we can make use also of a package called performance. So kindly, we haven't loaded this, pero ako na-load ko na siya, class. So I'll give you a minute, class, to install this package. Pwedeng gamitin si payload ni Pacman. And then, para diretso na, sige, I'll use payload. But I need to install first. I need to load first si Pacman. Pacman. Okay, once you're done, class, once you have loaded performance, kindly chat, please, so that I know if I may continue already. I will not show you, class, how to study the performance package. You know what to do, no? Documentation, tingnan nyo, tapos may mga examples. Okay, by now, you should have developed this habit of trying to look at the attributes or of the functionalities of the package. And performance is one of those. It's relatively new, no? Magandang package yan kasi marami siyang functionalities, especially when we're dealing with diagnostics. Okay, thank you, Mark. How about the others, please? Okay, good. All right. So my function si performance na model underscore performance, which will give us summary reports, a summary of the FIT1, will give us a summary of the regression outputs. Yan, no? So yung final model natin, yung FIT1, gives us a measure of the AIC, corrected AIC, Bayesian information criterion, the R squared, the adjusted R squared, the Ramsey, the root mean square error, and the standard error. Okay, standard error of the regression, 2.954. Especially this sigma, this will become important as we study more in greater detail in diagnostics natin. Okay, well, and then we can also control. This is that's why I like yung performance model kasi meron pa siyang function check model. Okay, let's run this. This will give us a plot. Okay, check model FIT1, control enter. Okay, it will give us a good plot about the regression diagnostics there. So check model yan, no? Okay. All right. So here we have Okay, you have 6 plots here. Number 1, you will find here this is the plot of your hourly wage. It's a density plot. So you can see here the residuals. Okay, this is to check yung normality ng residuals natin. And you can see here that medyo hindi normally distributed yung residuals natin. The normal distribution is the blue one here. Yung residuals natin, you can see here that it's not normally distributed. Okay? Ang ayoko lang dito is, let me see if we can. We can increase this using, dito natin check model pick one. Let me write it here in the console. Okay. Sometimes mas maganda dito ayan, okay, so this is a lot better. Ayan, zoom natin. Mas kita dito kaysa dun sa compared to the one that was generated in the script window. Okay, so this looks better, a lot better. And then of course you can adjust this, no? All right, so here we have, it's in residuals natin, no? And we can see here that it's not normally distributed. Here we have linearity. This is a check. Okay, you can see here that medyo yung residuals natin, di ba? It sorts of it has a for larger values of your fitted values, medyo mataas yung variance. So may pagka non-constant yung variance siya. Dito din, class, homogeneity of the variance. The reference line should be flat and horizontal. It looks like the reference is not flat and horizontal. So may issue tayo dito ng homoscedasticity or constant variance. What's plotted here is the square root of the standardized residuals versus the fitted value. Here it's the residuals versus the fitted values. Then we also have a plot on the variance inflation factor, which is a measure of multicollinearity. It tells us if our independent variables are highly correlated. From all indications, mukhang wala naman, low. And the metric that's being used is, for others, it's 5. Okay, for others, it's 10. So there are different standards. But what I've seen is mostly it's 10. Well, not mostly, but marami ding 5, marami ding 10. In this case, it tells us that, okay, wala namang more than 5, no, sa correlation ng mga variables. So civil status, education, of course si education at saka si civil status at saka si gender, since categorical siya. So that will not enter the picture as much as education and tenure. So ito yung binabantayan natin, si education at saka si tenure, yung correlation nila. And we saw that when we did the correlation, hindi naman sila highly correlated to education and tenure. And that's proof here using the variance inflation factor. So this is a test of collinearity, multicollinearity. Okay, so dito, class, sa plots na to, makikita natin, we can see here the diagnostics for our model. We can also see here influential observations. Okay, points should be inside the contour lines. Okay, there are some points here, 59, 112, 126, 74. Okay, and mukha namang wala namang influential observations. The data that I gave you, yung apat na yun, class, yung outlier 1, 2, 3, 4, yung sa Excel file. We will discuss that next meeting. Kasi titingnan natin, class, yung distinction between what's an outlier, what's a leverage point, and what's an influential point. What's critical about that is the influential point. Kasi yung influential point, that can really affect the value of your parameters, the value of your regressors, their coefficients. And if you're using the model to predict, tapos medyo na-affected yung mga values and parameters natin, then the chances are we will have off predictions. Okay, yung mape-predict natin ng mga values for your hourly wage, in this case, can be off. Why can it be off? Because hindi na yan yung best na ano, di ba? Ang effect ng heteroscedasticity borne out by some influential values is that we no longer have the best linear unbiased estimator. Okay, so we'll take a look at this. Ito yung normality ng ano natin, ng residuals. Medyo may problem siya dito. Okay, so that's what is generated by the check model. All right, so let's continue. Okay, so I gave here some some notes. Sabi natin, sorry medyo. So model fitting is just part of the story. Okay, it's not enough that we are able to generate using LM a model in R, and then we're able to interpret the meaning of the coefficients. We're able to come up with a final model. We have to do diagnostics. We have to test whether our model is follows the assumptions of your classical linear regression model. So once again, by way of review, ano ba yung mga assumptions natin? Number one, linearity. No? When we say linearity, it's the parameters that are linear. Okay, it doesn't mean that the relationship between your y and x is strictly linear. Kasi we said that x can be squared or x can be cubed. Okay, x can be logged. So linear pa rin yun. The expected mean outcome is linear in the function of the predictors. So that means that the expected value of y is equal to this is matrix form x times beta. Now x can be squared, x can be cubed, can be logged. Yung beta, yun ang hindi pwede. Hindi siya pwedeng square root of beta, beta squared. No? And the implication is that the error term, okay, the error term, the expected value of your error term given x should be equal to 0. Okay, so that's the implication. Okay, next, yung homoscedasticity. This is just a quick review of the requirements class. The variance of your error terms given your x values should be constant. Okay. Also, independence. Ibig sabihin, class, yung covariance na ano natin. Ayaw dyan na rito. Okay. Covariance ng error terms, epsilon sub I and epsilon sub j, given your x should be 0. The error terms should not be correlated to each other. Okay. The error terms, visually, the error term should not show a pattern. It should not show a trend. Okay, a pattern like fanning out or fanning in. And then also the normality of the residuals. Okay, although this is not a strict requirement, your epsilon sub I should be normally distributed with 0 mean and the constant variance, which combines ito yung requirement ng linearity, di ba? Ito. Yung una yun. This one. Okay. This one. And also yung homoscedasticity, yung variance should be constant. Okay. All right. Then we have other assumptions like multicollinearity. Independent variables natin, you should not be able to predict yung your independent variable from each other. And then also important yung outlier effect, which we're going to discuss next meeting, yung concept ng outliers, leverage points, and then and then the influential points. And this one also no measurement error and no specification error. Okay, when we talk of specification error, maybe the model should have your x squared, okay, and not necessarily x lang. Baka mas maganda na quadratic yung model natin or cubic yung model natin. Vis-a-vis just having a power of equal to 1. All right. So regression diagnostics requires that we evaluate. Okay, so this is part, kaya nga malaki din points nito dun sa paper nyo. So you need to look at your model. You need to look at the assumptions and if there are any violations of the assumptions. The data might contain influential observations such as outliers or extreme values that can affect influence or the result that can influence the result of the regression. Okay. All right. So let's first okay, tingnan muna natin class yung yung output natin, yung model natin. We can make use of, there's a function called glance. We can use that. So i-glance natin yung FIT1 na model natin. Okay, so glance. Okay, question. Anong package galing si glance, class? Somebody please? From what package is glance? Waiting for your response, class. Parang pareho lang to ni model performance, no? Although yung glance, mas maraming output na binibigay. So from which package, class, glance? Did you check, Jonas? How did you check? How did you know that it's from the Broom package?
I search, lang po, I searched it up po, sorry.
No? Sorry?
I searched it up lang po, from what main package it's from. Then I saw na part of the solution.
Sorry, sir. Hindi clear yung yung sinabi mo.
Sorry po, sir. I just got it. I just searched it up po. Kung saan po yung glance po, and then I saw po na it's part of the Bloom package.
Yeah. Oh, you're correct. You're correct. It's part of the Bloom package. Plus, I hope you know already how to determine from what package a particular function is. Ang concern lang natin dyan kung may conflict, no, between let's say, because a particular function can be coming from several packages. So you just have to know kung ano yung gusto mo, no, yung kunyari sa glance. What does this do? Okay. All right. So if you take a look at glance, may generics package, may JTools package, merong Broom package. So saan dyan? Class, no? From where? Kasi pwede siyang from this JTools, pwede siyang from generics, okay? But what we're interested in is from the Broom's package. So Broom, okay, so what does this do? Okay, here. These are, all right. Okay, so what does the glance package function do? It constructs a single row summary of a model or of a fit or other objects. Okay, so gagawa siyang, parang kanina yung model performance lang, di ba? Single row lang yun. Okay, so for this one, the same thing. Single row ng fit1. Yan. So there are 12 metrics here, yung R squared, adjusted R squared. Okay. Okay, anyway. Yung sigma, statistic, p-value, degree of freedom 1, log likelihood. So these are now measures for yung MLE, maximum likelihood, no? Number of observations, degree of freedom of your residual, degree of freedom of your regressors. Meron tayong deviance measures, measure dito, may AIC, BIC, etc. So you have here several metrics for your fit1 object. Now, just like yung model check kanina, we can also plot. Pwede natin gamitin si plot function, okay, using the plot function which is from base R. Okay, it will give us here, ang i-generate niya 4 na plots, no? But there are actually 6 plots that can be generated here. So here we have, ito yung, the first plot is your residuals versus fitted. So this plots class you can use. Okay, you can use this in order to do your diagnostic residuals study. Okay, and then what's good about, by the way, no? So pakita ko lang kasi actually plus reminder that you're required to submit a quarto document for this, which is actually easy kasi from the RMD file you can just save it as a quarto document. And the advantage of a quarto document is that, just to show you. Okay, so this is a quarto document. Okay, so medyo iba na yung interface niya, no? Okay. Dito sa quarto, hashtag and then pipe. Instead of putting some parameters here in R, pwede dito ilagay yun. And the advantage of a quarto document is that, okay, let me just show you. No? Okay. Let me run here yung plot. Let me run the plot here. Okay. Let me choose one first. Yeah. Okay. This is the first plot, a plot of residuals versus your fitted values. I can copy this image. Okay, and then I'll go to my quarto document. Asan si quarto document ko? Hindi ko pa nasi-save kasi. Ito yun. Control V. Okay. Take a look at that class. Straightforward na kagad, no? You can already copy-paste the image. Unlike sa sa RMD, hindi ka basta-basta pwede mag-copy image. Okay, I'll copy that here in RMD. Yung kinopy-paste ko dito, I'll copy it here. Okay, hindi pa pwede, no? Pag QMD file class, then diretso. Okay, then you can just put your discussion there. Okay. So of course sa R naman pwede naman ma-generate yung yung plot na yan using decode, no? Sa quarto, ganun din. You can run this code in quarto and then you'll be able to generate that. What I'm saying is that when you're looking at other images sa R, hindi mo pwede basta-basta pwede mo siyang i-copy paste but you have to code it, no? Sa quarto hindi na, diretso na, pwede i-copy paste mo ng diretso. And quarto will be the one to write the code dun sa pag-copy-paste ng image na yun. So which makes it really very convenient to work with the Quarto document. All right. Okay, so as I said, there are actually 6 plots here. No, let me show you. Plot. Okay, actually I did it here. Clear ko lang yung mga plots ko dito. Okay, when you use plot here, class, notice. Okay, notice plot fit 1. Okay, sabi hit return to see the next plot. So if I type 1, this is the first plot. Okay, return second plot, third plot, fourth plot. Okay, ayaw niya, no? Ayaw niya pakita yung fifth, although there's a fifth plot. So I'm going to show it here. Plot, fit 1, and then let me identify which, ito na dapat yung susunod, no? Is equal to 1. Okay, which is equal to 1 gives us the first plot. So, sorry, fit 1 dapat. Fit 1. Okay, so this is a first plot. This is a plot of your residuals versus the fitted values. Okay, if I type 2, what will the second give me? That's a normal QQ plot. So that's plot 2. And then you have plot 3. Plot 3, control enter. So this is the square root of the standardized residuals versus the fitted values. Okay, and then plot 4. Okay, you now have Cook's distance. Cook's distance is used to identify influential points. Okay, so may tatlong ano dito, no? Candidate for Cook's distance. We will have to check if these are really influential points. Kanina, di ba, dun sa plot ng model check performance, okay, and model performance, you notice that lumalabas naman na wala namang influential points. Okay, but these are potential influential points, and there are ways by which we can test if these are significant influential points. And then a fifth, number 5, control enter. Okay, residuals versus leverage. Okay, we're going to discuss leverage next meeting. Ano ba yung outliers? Ano ba yung leverage? Ano ba yung influential points? Ito na naman sila. Itong tatlong to, 59, 260, and 112. Okay, and then of course there's a sixth one, 6. Okay, Cook's distance. Yan. Okay, so all in all, there are 6 plots that we can generate from this plot fit 1. If we try 7, okay, error na, no? Wala na, only 6. So you can use those for your quiz. You can use those to do diagnostics on your model. All right? So tanggalin ko na to, no? Gives the first plot using which, alam natin yan, which is equal to 1 yun. Okay. All right, any questions so far, class? Clear ba? So actually, ito, 5 to, no? 5 to, no? Kasama yung Cook's distance, yung dalawang Cook's distance. Only that, hindi siya pinapakita dun sa sa plot function. You will have to indicate which is equal to, yung unang Cook's distance, which is equal to 4. Yung second Cook's distance, which is equal to 6. Okay, so those are the plots that you can generate and you can use to analyze the validity of your model. Okay, there's another function, yung autoplot function. Pareho lang naman yung generate nito. Although mas, ano lang siya, mas, let's say, a little bit, okay? Okay, may nakalimutan pala ako, no? How do we now create? Kasi class ito pala, no? Hindi natin nasagot. Which create as one plot. So plot kasi, di ba, of fit 1. Okay, and then we can make use of, if you want to generate the diagnostics plot in one plot, pwede nating gamitin yung par function. Par means partition. Partition natin yung row is equal to, let's try first 2 by 2. Okay. Sabi natin, di ba, kapag plot lang, it will generate only the four plots. If you want to generate all the 6, gagamit ka talaga ng which is equal to 1, 2, 3, 4, 5, 6. So let's run this. Partition, okay, MF row is equal to 2 by 2. Yan. So ang hindi sinasali yung Cook's distance, ang default ni R. Okay. Even if you rename this as 3 by 2, si 3 rows and 2 columns, hindi niya isasama, no? Okay. So I haven't really, honestly, I haven't seen a way. I've tried to research on that, no? Na ipakita yung 6. So far hindi ko makita eh. So maybe you can help me out on that. Diba kasi, kung i-which natin, which is equal to 1 up to 6. 6 diagnostic plots will be generated. Okay, even if we identify 3 rows and 2 columns, which makes it 6 elements, hindi rin niya hindi rin niya isasama. Okay, kahit pagsama natin to, which is equal to 6, even if you combine this, yung partition at saka yung which, if you run this as a whole, okay, yung 6 lang ibibigay niyo. No? Wala kasing which is equal to all. All right. So the 4 basic parts here of your diagnostics are yung 4, no? Ito, yung residuals versus fitted, yung standardized residuals versus your fitted, square root of the standardized. You have your normal QQ plot, and then your residuals versus leverage. Now it's important for us to understand what this gives us. No? Okay, so I already have here, although incomplete to, no? This is incomplete. You may, of course, wish to add more on this, do more research, understand more the regression or diagnostic outputs. Residuals versus fitted, it's used to check yung linear relationship assumptions. A horizontal line without distinct patterns is an indication for a linear relationship, which is good. Dapat to. Normal QQ plot, ito yung, this is used to determine whether yung residuals natin are normally distributed. Okay, so just to be clear class, marami ng research din nagsasabi na suppose your residuals are not normally distributed. It will not actually affect your blue, no? Yung best linear unbiased estimator. Okay, hindi siya makaka-affect. Especially if yung yung sample size natin is big, relatively big. So if your sample size is relatively big, then the issue of non-normality of residuals may not be that critical. Okay. And thirdly, you have scale location. So it's used to check yung homoscedasticity na yung variance ng residuals natin. Okay? And then yung number 4, yung leverage. Okay, ito yung sinasabi natin na kailangan ma-identify natin kung are there any outliers, are there any leverage data points, and ultimately, are there any influential data points? Kasi yung pinaka-critical doon yung influential data points. A data could be an outlier, or a leverage point, but it does not have any effect on the validity of your parameters. Okay? And then, as I said a while ago, itong autoplot function, okay, similar lang kanina dun sa sa partition natin. Okay, were you able to generate this, class? Itong autoplot fit1, kindly chat please. Were you able to run yung yung autoplot natin? Kindly chat please, class. Okay, thank you. How about the others? No. Aileen, ano lumalabas na result?
Error po, sir.
Error. Dali ah. So, could you kindly share your screen, please? Let's check. Maybe the others also have that. So my question dito si Jonas, that yes, it means na-load na ba natin si Tidyverse? If you haven't loaded Tidyverse, kindly load it, because Tidyverse will come with will also automatically load ggplot2 also. So Eileen, kindly load first Tidyverse, library mo siya. Okay, once you have loaded it, try again the function. If not, maybe we need to, kasi the autoplot function comes from ggplot2. But I've noticed that sometimes it will not run. You will have to load another package, which is gg45. But let's try first ggplot, the Tidyverse. How about the others, class? Okay. So, yung sinabi naman ni Pinying, yung LM daw, no? Autoplot is not supported by LM objects are not supported by. Who is this? Okay, Eileen. Okay. Have you loaded Paki-load na muna yung
I load the Tidyverse and ggplot2 pero error ba din po?
How about GG45? Try GG45. Wala dyan. You have to install it. Hindi mo linilipat yung yung environment. Okay. It's up to you. Nasa ilalim kasi yung console mo. Global options na lang. Hindi, letter F. GG45. Yan sa baba. 45 there. Yan, okay. So, it worked, no? GG45. So, hindi lang enough yung ggplot. Pero yung autoplot kasi it's from ggplot2. So, this is a strange occurrence actually. All right. How about any other questions? Thank you, Eileen. Thank you. Any other questions, class? Okay, no questions. Okay, let's proceed. Okay. So we're going to use the augment function of broom. Now, what's good about augmenting is that it will add. Augment means to add. Okay. So if we're let's create an object called fit1 and then diagnostic and then model. Okay. 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 Fit1 diagnostic will be fine. And then let's make use of the broom package, the augment function, so that we can create an object, fit1 diagnostic, okay, out minus, okay. That will, let me put here where this is coming from broom. And then using the augment function, it will generate an object which will include relevant data points, okay, augment, and then fit1. Okay, almost time, bilis. Okay, then let's see. Let me view fit1 diagnostics. Okay, so this is very useful as far as regression diagnosis is concerned. You have your hourly wage. You have your 4 variables. Okay, these are your 4 predictors. This is your dependent variable. You have your fitted value. Okay, you have your residual. Then you have that hat. Let's explain this next time na lang. Yung sigma natin, yung standard error. Then you have here your Cook's distance. Okay, the Cook's distance is supposed to be a metric for influence points. So next meeting, we're going to look into this. Kindly, as part of your, hindi pala, no? Next meeting, okay, please watch the video that I'm going to post. And if you're free class, I'd like to invite you to attend yung 2:30 class sa on Thursday. If you don't have any classes, please feel free to join us sa 2:30. I'm sorry I won't be able to join to be with you on Thursday because I'll be attending a seminar that will be for Thursday this week and Thursday next week. But if you don't have classes at 2:30, please join us. Pasensya na class kasi umaga yung yung seminar ko ng this Thursday at saka next Thursday. Okay, so
Sir, sorry
yes.
po.
Yes.
Required po ba na umattend dun sa 2:30 na class sa Thursday?
No, you're not required, class. You're not required. You're just required, please, kung pwede, to naka-share ba ako? Am I sharing? Hindi ba?
Sir, yung RStudio lang po kita namin.
RStudio. Ito?
Yes, sir.
Yeah,
Yes,
okay.
sir.
Yeah, ito naman yung pinapakita ko. Pero yung result class ng ng augment, ito, di ba? So meron tayo ditong ng Cook's distance. No? We have here the data for ito yung predicted value, ito yung residuals, and then ito yung Cook's distance, no? Standardized residuals and dito din. So the data that we need in order to analyze more yung regression diagnostics natin is already here. Okay. Okay, so next meeting class, itong gagawin natin, magte-test tayo for linearity. We're going to look at the reset test, si Ramsey regression equation specification error term. So just by way of review, okay, quickly lang to class. Ito, we're going to use the reset test. Okay. Reset test. So saan galing to? LM, no? Hindi pa na pala natin no? So kindly paki-load nga. Did I tell you to, Did I instruct here? Wala pala, sorry Sorry, dapat sa simula. Okay, I forgot to identify yung mga packages. Pload na kailangan natin. Control X. I'll just end in this one class. So tidyverse. Sino pa ba? Si Broom. Okay, si LM test, linear model test. Also si Sandwich. Okay. So these are the packages that we need. Okay. Mali spelling ko. So once you have loaded Pacman load, so next meeting class we're going to continue this reset test. Okay, mali spelling ko, reset test. Okay, and then FIT1. Okay. Oh, nangyari? May error ba siya? Kalianag. This one. Then we call it a day. Okay, take a look at this class. So FIT1, reset test. All right, p-value is this one. So please check kung ano tinetest itong Ramsey reset test na to. No? We'll continue with this next Thursday, pero as I said, I won't be able to meet you. Please, but if you can join our 2:30 class, but if not class, paki-watch na lang yung video. Kasi we will continue with this. Hopefully matapos natin tong diagnostic test next meeting kasi I'm really anxious to already move on. I-discuss pa natin, may mga natitira pa tayong topics sa regression like yung mga interaction, and then we will also do quantile regression, logistic regression, then pupunta tayo sa moderation, mediation, and then pupunta na tayo sa time series. So still quite a lot of topics to cover at so short a time. So medyo kailangan talaga ng siguro class, there are some topics there na i-record ko na lang for you to watch. Okay? All right, so let me stop recording now.